Hi friends, welcome to the dj.anshi YouTube channel. Today we going to discussing the concept of simultaneous ordinary differential equations. You know very well, if simultaneous equation will be given, then how can we find the solutions of that equations? Today we discussing if the simultaneous ordinary differential equations will be given, then how can we find out the values of x and y, that are the dependent variables. In this case, it can be solved by two methods. One is the elimination methods, another one is the substitution methods. In this case, x and y are the dependent variables and t is the independent variables. T is independent variables. The first problem is solve dx by dt which is equal to 2x plus 6y and dy by dt which is equal to x plus y. Call these equations are 1 and 2. Then use d is equal to d by dt. So you get dx which is equal to 2x plus 6y and dy which is equal to x plus y. So those equations can be written as dx minus 2x minus 6y which is equal to 0, and this can be written as minus x plus dy minus y which is equal to 0. In this case, you take x as the common factor, you get d minus 2 into x minus 6y which is equal to 0, and minus x plus you take y as common, you get d minus 1 into y which is equal to 0. For solving these equations, you multiply d minus 1 to these equations and 6 to these equations. Then you get d minus 1 into d minus 2 into x minus x into d minus 1 into y which is equal to 0 minus xx plus 6 into d minus 1 into y which is equal to 0. So plus minus ide eradu kuda 6 into d minus 1 into y ide, so they are get cancelled. You get d minus 1 d minus 2x minus 6x which is equal to 0. You get d minus 1 into d minus 2x minus 6x which is equal to 0. If you simplify this, you get d square minus 3d minus 4 into x which is equal to 0. Let us consider pi of d is equal to 0. What is pi of d? Pi of d is d square minus 3d minus 4 which is equal to 0. If you simplify this, you get two different roots. m1 is equal to 4, m2 is equal to minus 1. Therefore, x is equal to the complementary function which is equal to c1 e to the power 40 plus c2 e to the power minus t. It is also the value of the general solution which is equal to the general solution, because in this case particular integral is 0 because it is a homogeneous linear differential equations. In the homogeneous linear differential equations, the particular integral should be 0. So you get the x value, x is equal to c1 e to the power 40 plus c2 e to the power minus t. X value antane hyaಕೆ ಬರ್ಕೊಂಡಿದ್ದೀನಿ ಅಂತ ಅಂದ್ರೆ, in this case look here, x ಕೋಎಫಿಷಿಯೆಂಟ್ಸ್ ಇರುವಂತದ್ದು ಇದು. ಸೊ ಅದಕ್ಕಾಗಿ ನಾನು ಅದನ್ನ x ವ್ಯಾಲ್ಯೂ ಅಂತ ಬರ್ಕೊಳ್ತೀನಿ. ದ x ವ್ಯಾಲ್ಯೂ ಏನು ಅಂತಂದ್ರೆ c1 e to the power 40 plus c2 e power minus t. Then we find the y value. Y value ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಅಂತ ಅಂದ್ರೆ, you differentiate this equation. You differentiate this equation with respect to t, then you get dx by dt which is equal to c1 is as it is, e power 40 differentiation is e power 40 chain rule madadre 4 minus c2 e power minus t differentiation e power minus t into minus 1 ಇದೆ ಅಲ್ವಾ. ಸೊ ಅದು ಮೈನಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ ಅಷ್ಟೇ. Okay, then substitute equation 3 and equation 4 in equation number 1. If this called equation 3, this is equation number 4. Substitute 3 and 4 in 1. This is equation number 1. 6y which is equal to dx by dt minus 2x. Okay, so 6y which is equal to dx by dt is 4c1 e to the power 40 minus c2 e to the power minus t. This is dx by dt minus 2 into, what about x value? X is c1 e power 4t plus c2 e power minus t. Adon substitute ಮಾಡಿದ್ರು. Then you simplify this and you get a y values. That's about the problem number 1. Let me move on to the second problem. Solve dx by dt plus y which is equal to sin t and dy by dt plus x which is equal to cos t, given that x is equal to 2, y is equal to 0 when t is equal to 0. Let you consider these equations as equation 1 and equation 2. Use capital letter D which is equal to d by dt, then you get the equation 1 and equation 2 has dx plus y which is equal to sin t and dy plus x which is equal to cos t. Then you call this as equation 3 and equation number 4. Differentiate equation 3 with respect to t, you get the d square y plus dx which is equal to minus sin t. This can be written as dx which is equal to minus sin t minus d square y. You call this equation number 5. Then substitute equation 5 in equation number 3. You get minus sin t minus d square y plus y which is equal to sin t. So you get d square minus 1 into y which is equal to minus 2 sin t. Let us consider this equation as equation number 6. Let us consider pi of d which is equal to 0. Pi of d is d square minus 1 which is equal to 0. So then you get d is equal to plus or minus 1. You get two different roots. So the complementary function which is equal to c1 e to the power t plus c2 e to the power minus t. Okay, so then we find the particular integral which is equal to 1 by pi of d into f of t which is equal to 1 by pi of d is d square minus 1, f of t is minus 2 sin t. Is of the form sin ax format chalide. We replace d square by minus a square. So what about a value? A value is 1, so you get minus 1. So you replace d by minus 1, you get minus 2 into sin t by, you replace minus 1 minus 1 minus 1 minus 2. Minus 2 get cancelled, the particular integral which is equal to sin t. So y value which is equal to the complementary function plus particular integral. Why you write the y? Because in this case we see the y coefficients. Okay, so y which is equal to the complementary functions plus particular integral, y which is equal to, you adding both complementary functions and particular integrals, you get y value. Okay, when t is equal to 0, y is also 0. Put t is equal to 0. c1 e power 0 value is 1. So c1 plus c2 e power minus 0 means 0 e power 0. E power 0 value is 1 plus sin 0 is 0. You get c1 plus c2. If when t is equal to 0, y is also 0. So 0 which is equal to c1 plus c2. It is called it as equation number 8. This is equation 7. This is equation number 8. You differentiate equation 7 with respect to t. You get dy by dt which is equal to c1 into e power t, differentiation is e power t plus c2 into e power t minus t, differentiation e power minus t into chain rule minus. So minus na multiply madidini plus sin t, differentiation is cos t. Okay, then you substitute y and dy by dt value in equation number 2. So equation 2 is x which is equal to minus of dy by dt minus cos t. So which is equal to minus of dy by dt. Dy by dt is c1 e power t minus c2 e power minus t. Minus into minus you get plus c2 e power minus t plus cos t minus cos t. Then you get the x value. When t is equal to 0, the x value is 2. So you put t is equal to 0 and x value which is equal to 2. You get 2 is equal to minus c1 plus c2. This called it as equation number 9. From equation 8 and 9, you simplify this equation, you get c2 which is equal to 1. Then substitute C2 value in equation number 8, you get C1 value. That's about the second problem. Let me move on to the third problem. Solve dx by dt plus 2y which is equal to e power t and dy by dt minus 2x which is equal to e power minus t. Let us consider this as equation 1 and this as equation 2. Use d by dt which is equal to capital letter D. Then you write this equation as dx plus 2y which is equal to e power t and this equation as dy minus 2x which is equal to e power minus t. For solving these equations, you multiply 2 to these equations and d to these equations. So then you get 2 dx plus 4y which is equal to e power t minus 2 dx plus d square y which is equal to d into e power minus t. So then you get 2 dx minus 2 dx, they are get cancelled. D square y plus 4y which is equal to 2t minus e power minus t. D e power minus t is nothing but differentiation of e power minus t. The differentiation of e power minus t is e power minus t into minus. Okay, so totally you get d square y plus 4y which is equal to 2 e power t minus e power minus t. So then you take y as common, then you get d square plus 4 into y which is equal to 2 e power t minus e power minus t. Let us consider pi of d which is equal to 0. Pi of d is d square plus 4 which is equal to 0. You simplify this, you get the imaginary roots. Then the complementary function which is equal to c1 cos 2t plus c2 sin 2t. So then we find the particular integral which is equal to the 1 by pi of d into f of t which is equal to 1 by pi of d is d square plus 4 into f of t is 2 e power t minus e power minus t. Then you splitting, you get 2 e power t by d square plus 4 minus e power minus t by d square plus 4 is of the form e power ax format salida. You replace d by a value is 1. In this case d is replaced by a value is minus 1. After the replacing you get 2 e power t by 5 minus e power minus t by 5. Particular integral which is equal to 1 by 5 2 e power t minus e power minus t. So then y which is equal to the complementary functions plus particular integrals. You adding both complementary functions and particular integrals, then you get a y value. If you want a x value, you differentiate y value and you substitute y and dy by dt in equation 2. Then you get equation 2 is dy by dt minus e power minus t which is equal to 2x which is equal to dy by dt is minus 2c1 sin 2t plus 2c2 cos 2t plus 2 by 5 e power t plus 1 by 5 e power minus t. In this case minus e power minus t there, so you get minus e power minus t. So after the solving this you get x values. Okay, x value is c2 cos 2t minus c1 sin 2t plus 1 by 5 e power t minus 2 by 5 e power minus t. Okay, let me move on to the next problem. Solve dx by dt minus 7x plus y which is equal to 0 and dy by dt minus 2x plus 5y which is equal to 0. You consider these equations as equation 1 and equation 2. Use capital letter D which is equal to d by dt. Then these equations can be written as dx minus 7x plus y which is equal to 0 minus 2x plus dy plus 5y which is equal to 0. Okay. You take x as a common factor, you get d minus 7 into x plus y is equal to 0 minus 2x plus you take y as common factor. In this case you get d plus 5 into y which is equal to 0. You solving these equations, you multiply plus 5 to this equation, you get d minus 7 into d plus 5 into x plus d plus 5 into y which is equal to 0 minus 2x plus d plus 5 into y which is equal to 0. Then you change the signs, they are get cancelled. you write this as d minus 7 into d plus 5 into x plus 2x which equal to 0. After the solving this, you get d square minus 2d minus 33a into x which equal to 0. Let us consider pi of d is equal to 0. Pi of d is d square minus 2d minus 33 which equal to 0. Through the factorizations, you can't get the roots. So, by using d is equal to minus b plus or minus square root of b square minus 4ac by 2a formula, we can find the roots. So, you get d is equal to 2 plus or minus square root of 4 minus 4 into 1 into minus 33 divided by 2. A value is 1, B value is minus 2, C value is minus 33. After the solving this, you get 1 plus or minus square root of 34. You get two different roots. So the complementary function which is equal to c1 e to the power 1 plus root of 34 into t plus c2 into e to the power 1 minus square root of root 34 into t. In this case, particular integral should be 0 because it is a homogeneous differential equations. In the homogeneous differential equations, particular integral should be 0. So we get the x value. So the complementary function which is equal to the value of x, and also it is the general solutions. Then we find the y value. If I want the y value, we differentiate the x values. Then we substitute either equation 1 or equation 2. Okay, therefore the particular integral should be 0. The x value is c1 e power 1 plus square root of 34 into t plus c2 into e to the power 1 minus square root of 34 into t. You differentiate this, you get dx by dt which is equal to c1 into e power 1 plus root 34 into t is e power 1 plus square root of 34 into t. Then the chain rule 1 plus square root of 34 plus c2 is as it is e power 1 minus square root of 34 into t differentiation is e power 1 minus square root of 34 into t. Then chain rule apply madidre you get 1 minus 34. Okay, then substitutes x and dx by dt value in 1. What is equation 1? Equation 1 is 7x minus dx by dt which is equal to y. Then you substitute x and dx by dt value, y which is equal to 7 into x value is c1 e to the power 1 plus square root of 34 into t plus c2 into e to the power 1 minus square root of 34 into t minus dx by dt value is this. Okay, then you simplify this. Finally, you get y value as y is equal to c1 e to the power 1 plus square root of 34 into t 6 minus square root of 34 plus c2 e to the power 1 minus square root of 34 into t into 6 plus square root of 34. That's about simultaneous ordinary differential equations. If you have any doubts regarding this concept, please ask me in the comment section. If you like a video, please like, comment, share and also subscribe. Thank you for watching.